So for this exercise, find the components of the metric tensor in polar coordinates in the Euclidean plane R2. Wanting to compute the components of the metric tensor and using the polar coordinates ρ and phi, we start by writing the component g ρ, which by definition is equal to the inner product of the tangent vector e ρ with itself. Writing out the expression of e ρ in terms of the Cartesian basis, e1 cosine phi plus e2 sine phi, we find that this is equal to cos square phi plus sine square phi, which is equal to 1. Similarly, for the component g ρ phi, it is by definition equal to e ρ, inner product with e phi, which due to the commutativity of the inner product is e phi scalar e ρ, and therefore equal to the metric component g phi ρ. Writing out the expressions for these basis vectors, we find that this is equal to e1 cosine phi plus e2 sine phi, inner product with r times minus e1 sine phi plus e2 cos phi. Performing the inner products results in r multiplied by minus cos phi sine phi plus cos phi sine phi, which is equal to 0. Finally, for the metric component g phi phi, which is by definition equal to the inner product of e phi with itself, we take the expression for e phi and multiply it by itself, and performing the inner product we find r squared multiplied by sine square phi cos square phi, which is equal to r squared. Summarizing, if we represent the components of the metric in matrix form, that is to say, we put the components as g ρ, g ρ phi, g phi ρ, and g phi phi, this matrix is equal to 1, 0, 0 ρ squared. Please note that all the r's that we wrote before should actually be ρ's.